The second half of this section is about the law of cosines. The law of cosines is a little bit more complicated only because it has three separate formulas that go with it, but it's okay because each of them makes sense in its own way and they all have the same sort of relationship. So let's look at the law of cosines. The law of cosines, the first application, looks a lot like Pythagorean theorem to start out with. A squared equals. And the rest of the formula is based on the fact that we're talking about a squared. And so a squared is equal to b squared plus c squared plus, should be minus, sorry, minus 2bc cosine of a. And so what you see from this is that we have a relationship that exists. And so when I start to talk about b squared is equal to a squared plus c squared minus 2ac cosine b, and c squared is equal to a squared plus b squared minus 2ab cosine of c. Notice the relationship that exists here. Whatever it is, the side that you are squaring ends up being the angle that you're taking the cosine of, and the rest of the pieces involve the other two letters. So if it's a squared, then b and c are what you're squaring, b and c are what you're multiplying by 2, and you're taking the cosine of the angle. When can I use the law of cosines? If you'll notice, there's a lot of sides involved, and so you can use it if you're given side, side, side. So if you have three sides, you're going to use the law of cosines. Also, if you're given SAS, or two sides, one angle. So in general, if you have more sides than angles, you're going to use the law of cosines. Let's look at an example of this. In example 3, we're going to be finding the length of BC. Well, notice, I have two sides and one angle. And so that's going to tip me off that I'm going to use the law of cosines. Let's notice what we've got. I've got A, B, C. So when I set this up to solve for BC, what I'm going to end up doing is this. BC squared is equal to, now, look at this. This is BC right here, this side. And so what I'm going to end up taking the cosine of is angle A, because notice A is the angle that's opposite of it, and so BC, I'm going to have the other two sides squared, so AC squared plus AB squared minus 2 times AC times AB times cosine of A. It's just a matching game, guys. So whatever side I'm squaring, it's the other two sides that I'm going to use all of the used for the formula. So if I label this x, I've got x squared is equal to, now AC is 9, so 9 squared plus 14 squared minus 2 times 9 times 14 times the cosine of 62. Calculator in degree mode will allow us to do this. So I've got 14 squared, 196, this is 81, minus 2 times 9 times 14, minus 252 times cosine 62. So I've got 81 plus 196, 277 minus 252 times cosine 62. I'll just continue this up to the top here. 252 cosine 62 is about 118.306. So I've got 277 minus that answer. I end up with about 158.7. Guys, check check this out. That is equal to BC squared. So this is BC squared. So if I take the square root of that, I end up with about 12.6 is about equal to BC. Just like I told you, it's all about the formula. Use the formula, because when you use the formula, you can set up these ratios to give you what you want. Let's do this other example. If I'm going to find the measure of angle R, remember, finding an angle, probably going to use inverse ratios. So let's look at what we've got. The cosine of R is going to be what I end up solving for, because if I solve for the cosine of R, I can use inverse ratios. And so I need to look at the relationship here. If I'm going to use the cosine of R, I know I'm going to have to use this opposite side, because the opposite side is what's going to be related to that cosine of R. So 9 squared is equal to 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of R. This should be a 4. So this is 2 times 28, 56 cosine of R, and this is 16 plus 49, and that's 81. 16 plus 49, 65, minus 56 cosine of R equals 81. So I'll subtract 65. I get 16 type in a little cosine here. 16 equals minus 56 cosine of R. I'll divide by minus 56. So 16 divided by 56, and I'm going to take the inverse cosine of 16 divided by negative 56. So when we end up taking the inverse cosine of 16 over negative 56, we're finding an angle, remember. We're finding angle R. And so we have 16 divided by negative 56, and we take the inverse cosine of that because we're finding an angle, and we get that R is equal to 106.6 degrees. So the nearest degree would be 107 degrees. If we're finding an angle, we're going to use inverse ratios. So in these next 4 that you are going to work on, make sure you are trying to remember that concept. If you're going to use inverse ratios, you're going to be finding an angle. To find an angle, use inverse ratios. So in letter A, we have 2 sides in an angle, so it's going to be like the first one that we did. And when we have 3 sides here, it's going to be like the second one that we did. So go ahead and pause and write those down. Try these 2 as well. Again, one has 2 sides in an angle, so it's going to be like the first one that we did. One has 3 sides, so it's going to be like the second one that we did. Thanks for watching. Make sure you try those examples so that we can make sure that we are getting ourselves on track to be able to use law of cosines. Thanks for watching. We'll see you next time.